Okay, our speaker today is Charlie Hall, an old friend of mine. We worked together for quite a while. He has his PhD is from Chapel Hill, University of North Carolina, Chapel Hill, with H.G. Otis as his major professor, so we shared a major professor. He worked at Brookhaven. He worked at Cornell for 13 years, Woods Hole, Montana, and he's been recently, I guess for the last 10 years or so?
14 now.
14 now. At SUNY in Syracuse, the Environmental Science and Forestry Department. And he's been working on a lot of interesting stuff, but we convinced him to talk today on the geography and diversity of global oil supply. So, Charlie.
I'd like to clarify that I'm not from the place that plays basketball. That's Syracuse University. We are the state college across the street, SUNY, State University of New York College of Environmental Science and Forestry. We have a woodsman's team. And we're always looking for good students. It's a great place. Any of you are interested, you talk to me later. Obviously, oil is back in the news. How come it keeps coming back in the news? Probably most of you, but not all of you, are too young to remember the oil crises, but it was a big deal when they occurred in the 1970s, and everybody was busy installing wood stoves and windmills and all this kind of stuff. And then it went away, and now we've had the SUV revolution and all that sort of stuff. But the gas at my favorite gas station is now back to $1.80 a gallon, and people are talking about energy, about oil in particular, again. So I'd like to say what I'm going to talk about today is basically two things. I want to do a review of how we think about how much oil there might be in the future. And then I want to talk about some new work that I've been doing that's trying to explicitly get at how much oil there might be into the future and what we need to know how much oil might be available so you guys can drive to the ski slopes or run the University of Vermont or run agriculture in the United States or anything else that we do that requires oil. And just to give you an idea about how to think about it, every time you spend $1, about this much, what we call oil equivalent, this much oil or its equivalent of coal or something else, has to be taken out of the ground on the average and used to generate that dollar's worth of bagel or textbook or car or whatever it is that you're buying with it. Of course, for gasoline, it's you'd have to add in the energy of the gasoline itself. So how do we think about these issues? How have we? Didn't work. Okay, the first thing is to put all of this into kind of a geological or even historical perspective. This is 5,000 years. Humans have been on the planet as this species for possibly 5 million years, a little less than that. This is the time of Christ right here. This is the invention of the steam engine, more or less 1800. This is what we call the epoch of fossil fuel exploitation. It's also called Hubbert's pimple, and we'll talk more about Hubbert. And the important thing for you now to think about that is most of this is coal. Now, we're not talking about here really cruddy, low-grade kinds of energy like shale oil and stuff. If you want to talk about that, we'll talk about that later. But oil is some small part of that. Gas is something like oil in probably 85, 90% of Hubbert's pimple is coal. So, on a geological time scale, it ain't long. This is, I'm sorry, these colors don't show up, but it doesn't matter. This is from, I guess, 1850 to 2000 there. This is what is used as energy sources in the United States. Coal was dominant for a long time. Then oil and gas, which together we can call petroleum, are now dominant. They've been going back down a little bit, coal going back up, until recent years when gas has become a little bit more important. I don't think that's going to last for long. Electricity means hydro, and nuclear energy, or what we call primary energy. The United States is relatively unusual amongst countries in that a relatively small portion of our energy supply comes from oil. This has happened because of the oil crises in the 1970s. We basically stopped using oil for producing electricity and switched to coal, or in some cases, nuclear. Another way to look at it for the United States is, for the world, is humanity ran mostly on wood. If you haven't read Perlin's A Forest Journey, it's an incredible book about how important wood as a fuel energy has been in the history of the world. This hydrocarbons is now becoming dominant, although in the less developed country, hydrocarbons, coal is a hydrocarbon. I don't know why they came up with that. But anyway, this is coal and this is oil and gas, which around the world is becoming much more important. An important issue that we're going to return to, maybe the most important issue, I'm not sure, is how much energy it takes to make energy. What is your EROI, energy return on investment? To my knowledge, Bob, did we come up with this in 1984? Or did anybody come up with it before that in our science paper? I think, yeah, somebody before. Darn. Well, anyway, that's a pretty important concept. I originally personally came up with this. I'm an ecologist. I did my PhD on looking at energetics of migrating fish. And I was interested in how much energy a fish had to use in order to exploit spatially and temporally varying energy resources in its environment. Oil is really special because of its energy density, that you get an awful lot of energy in the relatively compact molecules of oil. So one thing is, people say, well, you know, there's always these transitions from one energy source to another, and when the oil's gone, we'll go to something else. But I think oil is really special for a lot of reasons. I've heard it say by my friends that are industrial chemists that 1,000 years from now, or maybe 100 years from now, people are going to say about us, you mean they used it for fuel? In other words, it's so valuable as a feedstock. I don't know. But anyway, I think oil is very special. Obviously, one of the reasons it's very special is it's damn hard to make an airplane fly on anything else. And even automobiles are tough. So, over time, this being a log scale, our ability to turn energy of one kind or another into oxidized non-energy, to take reduced carbons or whatever, including animal feeds and our feed, and turn it into oxidize into CO2 or whatever, is gone up enormously. We've made more and more machines that allow us greater and greater power. The net result, of course, has been what we call civilization and everything good and bad about that. Just to give you an idea, in the United States, from roughly 1850 to 1980, 1990, this is the percentage, sorry, I'm just learning how to use PowerPoint. The percentage of fuel, or percentage of energy that came from human labor, domesticated animals, and from fossil fuel. It's quite curious, isn't it, if you think about it? Economists still have labor in their production functions. But labor just doesn't cut the mustard. There are many reasons I have lots of complaints about how we do economics, but that's not today's lecture. I guess you read a paper on that if you've done your homework. Energy return on investment for oil in the good old days was really high, and that made us rich. That's why you and I aren't doing what my father did, which is carry the turds from the barn out to the fields. Because we've got cheap energy, it allows us to fix nitrogen, allows 2% of Americans to feed all the rest of us and a bunch of other people too. Haber process, who knows who Fritz Haber was? Probably the most important scientist that ever lived. Nobody knows who the hell he is. Isn't that amazing? He's the guy who figured out how to fix nitrogen. Very complicated, interesting fellow. Okay. Well, the thing is, oil in the old days was get 100 for one or something like that. This according to Cutler. If the numbers are wrong, they're Cutler's fault. Okay, no, they're pretty good. Most recent analysis I got was that we got back about 6 calories in the U.S. oil industry for every calorie we invest in getting it. So it's going down as we use up the good stuff. I just read something in the Wall Street Journal where somebody from the gas industry, some spokesman for the gas industry said, well, geez, we've used up all the easy gas in the 90s. I don't know if anything's happening in Vermont, but in New York we're getting hammered by gas being a lot scarcer. So gas is not exactly oil, but same things I'm going to talk about more or less apply. Incidentally, you can't get any money to study this stuff. I think it's the most important thing we can be studying, or one of them. No money, but lots of money to do lots of things, other things. Also carbon from coal, oil, gas, nuclear, wind, photovoltaic. The carbon question, of course, is very important. And natural gas, everybody, if you think anybody's cleaning up their carbon act, basically what they're doing is burning less coal and burning more methane, burning more natural gas. It's called use up your best stuff first. Really stupid to make electricity with natural gas. You ever think about that? You're going to need it to bake bread and for homes and so forth in the future. But oh well, we're not here to talk about policy. Real price of oil. Sorry for, again, we're back about here. Who knows what it'll be next month. Goes up and down. Okay, gonna make these points. Relation between economic development and energy use, importance of oil, and, oh, you can read it. I hate people who read their PowerPoints. But as I said, I'm just learning. Implications for the future. So basically, we're going to do a summary. Now, the first thing is, how important is energy in general and oil in particular? So if you look at South Korea, for example, a very successful example of a country that got itself richer. Call it a successful development. The economists like to take all kinds of credit for that, and you got to realize that they did it absolutely with everything opposite of what the economists in the World Bank say we should be doing today. They closed their borders. They didn't have free markets. They had government and interfering all over the place in their economy, and it worked great. That's South Korea. This is per capita wealth in constant dollars, corrected for inflation, and per capita energy use. Duh, I think there's a relation. Malaysia, China's down here, God knows where it's going, etc. The United States is kind of funny. We're different. We've become richer without using more energy. The question is, did we really get richer? I don't normally read the Wall Street Journal. I'm not into that kind of thing, but it was one in the Albany airport. And every economic indicator all around the world is except commodity prices. Hey, I didn't think it was supposed to work that way. And everything's down the toilet. So, I want to know. My mother, when I was 12, I asked her, what was the Great Depression about? My mother, bless her, is still alive. She told me, I still remember all kinds of things she told me as a kid. And she said it's when people thought they had more money than they really did. That sound familiar, folks? So I'm kind of curious where this is going to settle down. Maybe we haven't gotten a lot more efficient, or maybe we just exported our heavy industry so our oil is refined in Mexico and our steel is made in Korea and so forth. Or maybe, in fact, all the technological cornucopians are right and we become more clever. I can't get any data to figure that out. I can't see anybody who's asking the questions in any, I think, insightful way. Are you? Maybe you. I mean, you're our only hope, Bob. If Bob is our only hope, we're in big trouble. If you look, no, Jesus. I don't know what. Hey, man, we're really wired here. I don't know what the hell to do with this thing. There's no clip. I lost my clip. Oh, there it is. All right, if you look at, we're supposed to be getting more efficient, but if you look at all these different countries here, you look at their production of GDP per unit of energy, none of them get any more efficient. Maybe they do, maybe they don't. But you tell me what the trend is of all those lines. No clear trend that I can figure out. So if you want to get rich, if you're a poor country and you want to get rich, the way to do it is to use more energy. Boy, that sounds like a good solution for our carbon problems, huh? The CO2 problems. And the thing that economists don't get, most of them at least, development economists, and all you got to do is read Stiglitz and Easterly, which I just did in a class, and where are these guys coming from? These are the best critics we have, and they're great, but they only go about 5% of the way of what we need to do. Costa Rica, for example, has used 3 times more energy, twice as much energy as when I first went there in 1977. I just talked about Costa Rica in another class. And now but they're not any richer. Why? Because the population growth rate is almost exactly the same as the energy growth rate. You look at a country that got richer like Korea or Malaysia, their energy growth rate is faster than their population growth rate. So if we can't get more energy, there's only one way to get richer, get poorer. I mean, get less numerous, I think. I don't have any counterexamples. Let's get on with the main thing. Energy use. We're still using more, even in Canada and the United States combined. Latin America and Caribbean, they don't look like much slope to those, but since 1970, it's increased by about 2 to 2.5 times. The growing economies of Asia are using lots more energy and maybe slowing down. I don't think China is. How important is oil? Well, globally, about half, the blue there, about half of the total, not quite. Pretty important. Depends what country. For the U.S., this is an interesting graph out of the New York Times. There's the U.S. up there, and all of these arrows are pointing towards the U.S., and this is where our oil comes from. Predominantly from Canada and from Mexico, from Africa, Nigeria especially, and from, of course, the Middle East. And the circles are roughly proportional to supplies. When will the end of cheap oil come? Isn't that the question? So how many of you know of Campbell's paper, The End of Cheap Oil? There's always going to be enough oil around to oil your bicycle chain. Don't worry about that. But when is there going to be, how long will there be oil that's cheap enough to do what we do with it, use it for all of our luxury transportation and all the other stuff that we use? Well, that's a good question. One way to think about it, and we're going to come back to this, is this is a geologist's view of how much of a resource, whatever it is, there is. And there may be a tremendous amount of the resource. But the amount of reserves that we have that are measured, that we really know we have, is this first little box up here. So for example, in the US, there's about 23 million barrels of oil. 23 billion barrels of oil. That sounds like a lot, right? But if you divide it by 260 million people, it's about 80 barrels of oil apiece, you know? That's kind of like something this big. That's how much oil that we know we have in the U.S. Now, they hope to find more. George Bush wants to crank up the oil exploration. Now, there's undiscovered hypothetical reserves. That's pretty hard in the U.S. because there's not enough room between the boreholes that we've looked for oil for there to be significant reserves left. And speculative means, I don't know, speculative. Now, also, this stuff is called economic. That means at current or foreseeable prices, it's worthwhile to get it. There's lots of oil we know about. In Venezuela, for example, Kern River Field in U.S., a few other places that maybe we can get, but it'd be pretty expensive to get it. So if oil went up to $100 a barrel, but we'd have more oil. We're going to come back to this picture because we've got to think about it some more. It's a very important graph. Now, the estimates of how much oil we have of course, and we're going to come back to this again and again, these are the old ones by Pratt and Weeks in the U.S. This is for the U.S. It's called EUR, Estimated Ultimate Recovery, meaning the oil that you already got plus the oil you hope to get into the future. And they were all around a little more than 2.2 trillion barrels for a long, long time. The USGS has just come out with a new resource estimate that goes up to 3 for the world, or even 4. The 3 is what they call the 50% probability of finding. The 2 is what they call the 95% probability of finding, meaning almost certainly we'll find it. And out here is the 5% of finding. But you have to realize the main reason it's jumped from all these earlier estimates of around 2.2 up to about 3 is that they assume a technology factor. And the technology factor is around 0.46 to 0.5 increase due to technological improvements such as directional drilling and so forth. Now, one thing you have to realize is that technology has always been a factor. Technology has always been improving. Are we improving technology faster today than we did in the past? Another thing that's important about this is that we found our oil in the world and in the U.S. at vastly, vastly greater rates in the past with the technology of the 1920s and 30s. So, it's a race between increasing technology and decreasing quality of the resource, of the possible resource that you're looking for. How high is the quality of your probability of getting this resource and of the economic and energy costs of getting it? Okay, methods for forecasting oil production. I like this little picture here a lot. That's what we're going to do now for a while. And we think we got some new tools to think about here. And I'm going to focus mostly on the Hubbert because probably most of you, how many of you heard of Hubbert? Gosh. Second most important scientist in the United States, and nobody's heard of him. Well, there he is. I knew him fairly well at one time. And basically, Hubbert said this. In 1955, he said that we've discovered this much oil, and if you look at, boy, I've got to put in the U.S. picture. The U.S., the curve peaked in 1980 and came down. Oh, that's his global. Yeah, U.S. was about like that, okay? Sorry. And Hubbert predicted we would peak in 1970, which we did. He predicted that in 1955. Everybody goes, poo, 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 you can't be right, and all of that kind of stuff. So Hubbert got a lot of credibility for predicting correctly the peak of U.S. oil production. Now, the most important thing that Hubbert did is not to say how much oil there was, because he used the estimates of Weeks and Pratt and his own good judgment, but that we would use over time a resource in something like a normal curve, that it would increase exponentially at first, then sort of linearly go over the hump and go down on the other side. Now, that's in fact what we did in the U.S., especially the lower 48, which he was referring to. We did exactly what he said. And now in the U.S., we're about there, halfway down the other side. How many people know that U.S. was the largest oil producer within my lifetime? Well within my lifetime. How many people know that we had almost as much oil in the U.S. once as Saudi Arabia? And how much have we got left now? Not much. We just used it up. How much is left? And we can talk about that. Now, these neo-Hubbertarians, that's my word, people like Campbell, Lahari, and Duncan and others, are the new Hubberts who say, well, let's do this for the world. Now, the interesting thing is Hubbert said we would peak in the last picture. I'm sorry, I should have shown you. We go back here. last picture. Hubbard said we would peak globally if we had these larger resources in 2100. This is sort of the mean of the USGS estimates. That we'd peak around the year 2000. Obviously, we haven't yet, so obviously Hubbard was wrong. And he also said we'd peak in U.S. gas production in about 1980. And now we're, I don't know exactly where we are, but around the peak, maybe. Maybe we'll even go up some more. So Hubbard was 1 for 3. Not bad. Not great. Or was he? I mean, what's going on? Well, we had the crises of the 1973 and 79 oil crisis, which went over into the 1980s, caused large economic dislocations all around the world, probably exacerbated by government policies, but that's, you can argue with your Ronald Reaganites on that one. And the thing is, see that little faint pencil mark I drew in there? We're just looking at the top one, global oil. You know, probably if we'd kept growing at this rate, we'd be there now. And Hubbard didn't take into consideration that we would have an economic downturn. So now Campbell comes along and says, well, now the peak will be, depending on which of his papers you read, somewhere between 2003 and 2008 or something like that. So again, what's the area under the curve? How did Hubbard come up with the area under the curve? How does anybody come up with the area under the curve? And I'm going to tell you right now, I don't know the area under the curve. They're all educated guesses. They're all done by expert opinion. So I can't tell you for sure what the area under the curve is, but I can tell you the consequences of some different estimates of the area under the curve. Oh, God, I told you all that. Now, the U.S. Department of Energy doesn't want to scare anybody. So they don't want to have this Hubbard curve coming too soon. This is for global oil production. So instead of peaking in the middle, they peak at 70% of its ultimate use or something like that. Now, we have no evidence that this is possible. But it's interesting to think about. I think there's a lot of people in the business of making sure we don't get scared, something like that. All of these things we can talk about. I only got 45 minutes. I'm just going to. Hubbard's, there's this equation. So what's reality? Reality is all kinds of things. India looks like it's going up and then maybe approaching some Hubbard peak. Romania used to be a real important oil producer. That's just going down. U.S. looks like Romania. United Kingdom has a double peak when they made some later investments. All of this from the North Sea. Without the North Sea, Thatcherism would never have worked and Britain would be dead. But it did. There it is. And then you have Iraq. So with a lot of political jerrying around. We tried to fit some Hubbard peak. This is what we tried to do first and we gave up. We were trying to look at it country by country. That's the main thing I'm going to talk about. How do you do it country by country? And you can basically, it's free-form parameters, free-form modeling. You can basically come up with whatever you want. We had to be better constrained than we would be by trying to do this Hubbard approach. So I don't want to talk about that because I don't like it. All right, so let's show you what we did. I'm not standing up yet. How much time have I got? All right, about right, okay. So let's just look at some particular countries. Now, this is the interesting thing. Oil-producing countries don't just produce, they also consume. And this is what's new about the work that we're presenting now. So here's the U.S. This is up, here's today. This is a projection, we can talk about it, just accept it for the moment, of U.S. oil consumption if we keep going the way we're going into the future. And this is production, which is just going down and down and down. Even that's pretty optimistic, but let's say that's what it is. Now, the interesting thing is, remember Mexico. Mexico was pretty important for us. We've redone this just because we think that peak is a little too sharp, but let's not worry about it right now. This is a Hubbard curve from Mexico with the USGS best estimates. In other words, things that I think, I didn't say this before, I think the USGS median projection is ridiculously optimistic, with this assumption that all around the world we will increase our oil production by 50% above all of history through technology. Okay, we might. So this is sort of a either average case, if you believe the USGS, or pretty optimistic case if you believe people like Duncan and Hall and others. Or maybe we don't know. But the thing that's happening in Mexico is that Mexico is now using about half the oil it produces. The Mexican economy is growing like crazy. Taking all our jobs, or producing us cheap goods and services, or whatever you want to say. It's called globalization. And so their economy is growing like gangbusters, and of course they're using more oil. If you've been to Mexico City recently, let me tell you, they use a lot of oil. Now, the interesting thing for us is at some point in the future, these two curves will cross. In oil production to the rest of the world from Mexico, our term is wink out, like lights wink out at night when people turn them off. Mexico will be producing lots of oil, but we won't be getting it. Remember, Mexico was one of our largest suppliers. Canada, same thing. Conventional oil in Canada might be gone in 3 years. Now, there's a lot of tar sands. That's a different issue. We can talk about it if you want. United Arab Emirates got a lot of oil. Not many people living there. But still, you know, the amount of net production is going to decrease over time, maybe something like that curve. The swing producers, Saudi Arabia, Iran, Russia, Kuwait, Iraq, United Arab Emirates. I mean, those are the guys that hold the cards because they can continue increasing production. At least we think. A friend of mine was talking to a Saudi petroleum engineer, and he says, where are you guys going to get all this oil from Saudi Arabia? It's not here. Where'd you come up with these numbers? I don't know if it's true. If it isn't, we're in big trouble, folks. Okay, so here's our most recent estimates for a number of countries. United States, over the hill. Saudi Arabia, they don't use much, unless they go into desalinization in a big way. That could be interesting. Former Soviet Union, these are going to be big suppliers. These are the biggies. And they'll have the energy in the future. The middle producers, China. China has already crossed, has winked out, and is, now remember, this isn't just the oil that's been found. This is the oil that they expect to find, USGS 50% scenario, and with the expectations of this 50% technological bonus. Mexico, we've seen that. Norway doesn't use much. Not many Norwegians. Angola is going to be important. Canada is going to wink out pretty soon. That's conventional oil. UK, pretty soon also. And that seems pretty clear. They just don't have the reserves. So, what happens when you put all of these things together, and I want to talk a little more about the uncertainty, is that this is the estimate of oil reserves in some of the important countries. And you see they all tripled or doubled their oil reserves in 1 year. A year in which drilling activity was unusually low, incidentally. And this was a political thing that OPEC said you can produce according to your reserves. So bingo, all these reserves came. Now, we don't know if that oil is real or not. So maybe these estimates, I mean, obviously we're not walking around in Saudi Arabia now, guys from Exxon or something estimating their oil reserves. I don't think they'd probably be very happy to have us in there. So we just don't know. We don't know a lot about this. let's come back to this diagram for a minute, because what's really important about this, and about which, as far as I know, we have zero research going on. I've got a sophomore working on it. That's about where we're at. Is what's the energy cost of going from here, finding this additional oil. I was just down in Louisiana. Southern Louisiana is the most mind-blowing place I've ever been. It's more mind-blowing than any European country I've gone to. And I go and it's biologically mind-blowing. It's mind-blowing because of me just trying to understand the ecological street smarts of my friend John Day. And it's mind-blowing because you're standing there at the edge of the Mississippi River and you're looking out and there's oil rigs all over, oil rigs as big as a city, certainly as big as Burlington. And I said, how many of them are there? And they said 6,000. 6,000 oil rigs. Now there's no iron in Louisiana, no iron ore. How the hell much energy did it take to make all those oil rigs? So the energy cost of getting additional units of oil, or maybe of maintaining the aircraft carriers to ensure oil flow. I mean, how much of this do you put into the equation? And the energy cost of going after sub-marginal or marginal and sub-marginal deposits. That's what we got to know. That's why I can't answer this question. But I'll show you the best that we can do. Oh, implications for future. You can figure that out. Which USGS estimate do you believe? Well, those are various USGS estimates and how much oil we'll have in the world based upon them. This is the rate at which we find oil, discovery rates. You can do any of them. We don't have a clue. Oh, I don't want to. These are all scenarios that we did. I'm going to just tell you a summary what they mean. But if you want the numbers, I got them. That's the point of showing you these spreadsheets. Right? Now, basically, this is where we end up. If the pessimist, are they pessimists or not? Are we a pessimist if we assume that there isn't much oil left and we are conservationists? I mean, biological conservationists. We won't get into that one. How much oil is left? Well, if oil keeps going, this is the low growth scenario. We have two scenarios from the energy information industry. We did it country by country. I'm going to say we did this all for 38 oil producing countries, country by country. We did it. John Halleck did it with heroic spreadsheet analysis. I did it with a computer simulation. We get all the same answers. So I'm pretty confident, given the uncertainty in the data. If the low growth scenario is true, and the demand is what Campbell thinks it is, not USGS. Maybe you could say it's the lowest you could squeeze out of the USGS numbers. Then we're there. Now, this is interesting. This we found out, we didn't even know. This is assuming that we can increase production in the Big Seven, or all countries remaining with oil, by 5%. If we assume 7.5%, we can prolong things for another couple of years. 15% gives us 10 more years, a little more. So a real limiting factor here is what are you willing to pay for your oil in order to pay for the investments required to make up for declining production and declining net exports from Mexico and England and Canada and all of these countries. And one of the main conclusions that we come from this is that depending on the scenarios, you go from 30-odd oil exporters today to 7 by 2030 to 2050. Lifetime of many people in this room. So it's not that we're going to run out of oil. I mean, it'll be kind of skimpy. It's going to come from relatively few suppliers. This is a no-brainer. I mean, really, don't we know this? So here's putting all of our results together. And this is high growth, high economic growth scenario. And believe me, every economist, every country leader wants to have high economic growth, which we would probably translate into high oil growth, unless we do something remarkably different. This is our low growth scenario. And this is low ultimate resources, middle ultimate resources, and high ultimate resources here. So you can move the point where supply leaves demand with low growth and this very high estimate of oil possibility, then we don't reach this Hubbard peak, as it were, to 2040 something. If the low estimates are correct, and our spot checking indicates that's where I put my money, then we're pretty close to there. That indicates Campbell is kind of close. And a really important thing is how much money and energy are we willing to devote to 0 minutes left. There are 2 slides left. So here is total oil production in one of our sort of middle range scenarios. And this is how much comes from the big 7. There they are. And this is how much comes from everybody else. And this is where various countries wink out as oil suppliers. Incidentally, the oil minister of Colombia says they're going to be dead in 5 years. Indicating the USGS estimates are, even the medium ones, are vastly overestimated. Now, there you go. I'm out of time, Bob. Okay. In time, at least.
Okay. You can pass your questions to the sides.
Is this like a court?
Go ahead, sir. Some of these are going to be on reading that you sent around.
Could you bring that up? Yeah, because I got some extra information.
All right, these questions are from the
Can I have your names, please?
I'm Dave.
Hi, Dave.
This is Steffi.
Stephanie?
And Dylan.
And Dylan? I figure if I know their names, it'll be a little easier on me. Yes, Dave?
All right, these are all dealing with the paper that we read.
Yes.
Which was dealing with your economic theory, or model, biophysical, yeah.
Okay, okay.
So they have nothing to do with oil.
Has everything to do with oil.
Well, yeah, all right. Is it appropriate to have just one economic model for the entire world?
How do I answer that? If it's mine, yes. If it's somebody else's, no. I'm not. Well, I think the biophysical model in some way has to be true wherever you do it. Incidentally, I brought a few extras if anybody wants one and didn't get one. I have some extras. So, anybody want one of these incidentally right away? Okay. Try to share them. You run up and get a couple there, a couple there. Okay, yeah, go ahead. Sure. Well, there's models and models and models. Do I believe that my biophysical model of an economy is better than what you learned in Econ 201? Here is Econ 201 model, and I'm not going to explain it. And here's Charlie's model that includes all the material. Don't laugh, it's pretty simple. But it includes It starts with these important components of nature that are important inputs to the economic process, without which you cannot have economic activity. It's not as complicated as you look at it. The global water cycle, the sun, formation of fossil fuels, and then this is what humans do. Yeah, I think this model is absolutely 100% correct in any economy to which it would be applied, given that there are all kinds of different subsidies, all kinds of different intrinsic initial resources of the different countries. I suppose different people have different degrees of cleverness at exploiting resources, which either means that they're going to be richer or that they're going to run through the resources faster, depending how you want to look at it. But I think that this basic model, I would think is, well, I mean, if you're dealing with some Indians in the middle of the Amazon that haven't been touched by industrialization, then oil wells, of course, would not be appropriate for them. So the short answer is yes.
One more thing we're reading, a lot of people asked, basically, was there a specific event that encouraged the change from classical to neoclassical economics?
Yes.
Do you think a similar event is needed for this? What was that event?
Interesting. The event he's referring to, classical economics is the economics of Adam Smith and Ricardo and Karl Marx and I don't know, Alfred Marx, or maybe I don't know. And it focused on production and labor as a component of production, important component of production and other things. And I'll tell you, reading Ricardo today is fantastic. Ricardo was one smart cookie. And one thing I think about ecology, this is an aside, and I also think about economics, is you want to go back and read the first great people who wrote about the subject. Because they went after the juggler, they went after the main points, and the rest of the, in ecology, people are just kind of sweeping up the edges. So I like to go back and read some of the old papers. And do that in my classes. So the event that occurred that displaced these great thinkers from the center of ecology, of economics, is they couldn't solve the diamonds versus water paradox. And the diamonds versus water paradox is that how come diamonds are so costly in the market and yet they have so little utility or so little value, and where water is the most useful thing that there is, and yet it is very cheap unless you buy it in those bottles. And so this is the diamonds versus water paradox. And I don't know. So they asked me in the class that I was in before, how come they don't teach this in all classes of Econ 201? I don't have a clue. Because they're teaching people, excuse me, bullshit. Because it isn't true what we're teaching in Econ 201. And those ideas that are based on these models go all the way up to the top of our government and form the basis by which we make decisions, where I think you could start here. Now, who can do it? There are not many people doing this with me and a couple of graduate students and 10 or 20% or maybe 50% of Bob and John's doing some good stuff. And I'm pretty much running out of people. And we're not even that good. So I don't know what it's going to take. Next question. I mean, I looked at the wall.
What is your thought about increasing oil production in the U.S., specifically for ANWR?
Well, ANWR, it's there so we can just go with it. I mean, how much do you want caribous and how much do you want oil? So, I mean, it's your own choice. I mean, what do you choose? Do we vote on it? I mean, we know what it is. The oil's there. It'll be cheap to get out, and we're sure going to need it. And it's going to mess up the ecosystem. So, what's more important? So, it's a personal decision. What I wanted to show you is that if we increase the price of oil, I got it. We're going to go and drill some more. And this is something I did, well, in fact, I did this with Cutler Cleveland a long time ago. Hope I got all my graphs here. And we did this a long time ago, and we looked at basically what's a Hubbard analysis, a slightly different Hubbard analysis. In the barrels of oil you find drilling in the United States. And the data is the A's. And so the yield, the barrels found per foot drilled, went from 33 down to 12 and a half, you know, from 1944 or so to 1960. And everybody said, not everybody, Hubbard only said, we're really having a hard time finding oil. It went way down. And then, but then it went back up. And everybody said, technology to the rescue. And then it went down again. This is the first project I gave to Cutler when he was a junior. I don't know how many of you know Cutler, but incredible. God give me more students like Cutler. And so if you look at, I'm going to do some simple statistics here. You look at the residual. The residual is the difference between the model, which is fitting your best straight line to the data that explains 50% of the data. You get, the residual looks like this. You see it's same time scale on all of these. It's high, and then 0, where the model and the data agree. Below the negative here, 0, high, 0, negative. It looks like this. And I said, geez, there's a real pattern to this. And so I said, Cutler, do you have anything on effort? So we went and plotted effort and put effort like this. I said, geez, I think we got something there. So we did an inverse. They did not cheat. What this shows is that the harder you drill for oil, the less you get per effort. Throwing money at the oil industry doesn't find more oil. It just finds oil less efficiently. Because they go and drill in areas that aren't good to drill. And that's a big problem with our present plans from the administration. Y'all understand that? It's a beautiful example of statistics. It's so clean. So when you put the two of them together, the secular decline, the decline over years in an inverse function of drilling, then you get an R squared of 0.92. So, does that answer your question? We can't get more oil simply by drilling more. Next question.
This is from the audience.
In the U.S., excuse me. Yes. Go ahead.
Why do you think that demand for oil will continue to grow exponentially in the future? Is it purely because of population growth?
That's 1% in the U.S. The first thing we got to do, if you, I'm not particularly interested in policy. I'm a scientist. I'm just interested in the science of human-dominated ecosystems. I'm an ecologist. I say, what's going on? Now, if you want some policy things, I'll put on very uncomfortably, I'll put on a policy hat to say, well, you want to do anything about this, you better start reducing the population. And you think you ought to do it here, you sure better do it in Costa Rica because it's going to be a lot worse there. It's going to be a lot worse all around the world because they're more dependent on oil than we are. Sure. It's a no-brainer.
In the gas shortages in the 70s and 80s, the government turned to...
And in 2003.
And in 2003,
yes.
The government turned to tar sands and oil shales to get oil, but abandoned these efforts soon after due to the extreme costs. Do you believe that tar sands and oil shales are viable energy sources for the future, or are they too energy cost and labor intensive?
I don't think labor is an issue. We want to put people to work. We don't want to put energy to work, don't we? I mean, it's the opposite of everything they're trying to do in the economy. So, I don't know. Canada makes 20% of its oil from tar sands. I don't know what the energy cost is already. They've only been doing this for a little while. They got a lot of it, and they've already chewed up an area that on the satellite photos looks bigger than Calgary. So, if you don't care about the land, and I have no idea what the energy return on investment is for there, and I've spent a lot of time trying to figure it out. You know, people don't think that way. They only think in dollars. But dollars, of course, only have value in terms of the energy behind it. It's crazy. Basically, we're not doing any research in this country that's going to help us understand what the hell is going to hit us like a freight train. Yeah.
Are you optimistic about the role and value of technology, such as alternative energy sources in all of this?
What does optimistic mean? I mean, if we continue this assault on the environment because we have the energy to do it, is that an optimist or a pessimist? No, okay. Do I think think technology can make a contribution? It always has, of course. Do I think technology can make up for resource depletion? Probably not. Probably no way in hell. But nobody ever asked the question that way, so, you know, we basically don't know. So, do I believe in windmills? Yes, I think I believe in windmills. But even Grandpa's knob, who knows what Grandpa's knob is? First windmill was there. It blew over before it had a net energy profit. Now, I guess the ones they're making now, if you don't mind getting bird soup, are pretty good. And, yeah, I kind of like windmills. Let's do it. Give it a shot. I like nuclear. I'm an ecologist, folks, and I like nuclear, but not the way we do it now. But we could do nuclear pretty well. Then I'd have some hope for the future. I think we're going to be burning coal. That's what we're going to be doing, because we got it. Next.
Would biophysical economics have any impact on the conservation of wilderness for the benefit of wildlife and its spiritual and intrinsic values?
I think that's a value judgment question, and I don't think biophysical economics has a better or worse moral. I mean, it can give you information that might help you form your own moral or value judgment about what you should preserve or not. I mean, if you ask me, I mean, why did I get into this game? Because I love rivers, I love fish, I love birds, you know? Do I want to preserve these? Yes. Do I want to get rid of half the people on the planet to do so? If I could do so painlessly, I push the button. But I don't want to cause human misery. No way. These are complicated issues. Yes, I would like to preserve the birds. Thank you. And you don't do it through shade coffee, incidentally. That's another question.
Another question from the reading that about 4 people were wondering, do we understand nature's energy flows and the interconnections of everything well enough to model them, because you did?
Ask my critics, I don't know. I think I do all right. So how good are your models, Bob? Not bad. Yes. Do we have all the details right? No way. That's for you, the students, to figure out. We got lots more to do. I think we got the basic stuff down. Yeah. I've got all kinds of validated models in my.
This is from the audience. Why are the USGS estimates so inflated?
Why are the USGS estimates so, did you say inflated? Large. Inflated is yet to be found out. Any geologists here? Why aren't there people here from the geology department? I don't have a clue. Because they believe the technology. I believe most technology is throwing more energy at the problem. Agriculture technology, for example. So, don't know.
When do you think the ERO of the US will be 1/1?
Soon. If we implement President Bush's drilling plan, very soon. It's gone from 13 to 1 in 1980 to 6 to 1 today. So cut in half. Now, are we going to go down like this, or are we going to go like that? If we go like that, then I don't know. Soon.
How do biophysical, ecological, and evolutionary economics differ?
Biophysical.
Ecological and evolutionary.
Ecological economics is much broader and more encompassing. And it's Bob Costanza, because he represents wonderfully all these different things that are part of what he drew in his first article, which is very good, in the first issue of Biophysical Economics. Every place that ecology and economics overlap. Now, I personally have trouble with putting a dollar value on nature services. I think that so a biophysical economist might not do the same thing as an ecological somebody from elsewhere in that overlapping area. So I think if you went and got a hamburger, that maybe you should pay for it in grizzly bear habitat units. Because if you buy a hamburger, then somebody's going to cut a forest to grow more cows in Montana to make more, Costa Rica, something, make more hamburgers, and that's going to interfere with grizzly bears. But I don't think we should be paying for our hamburgers in grizzly bear habitat units. And quite frankly, and this is the only important place that I disagree with Bob, and I don't know that I'm right. And I want to tell you, I support all of his efforts to try to put dollar values on nature. There are many good reasons for doing it, but it's not where I'm at. Because what dollar value would I put on my love for my wife? It's just the wrong scale. And so, what dollar value, you know, what value do we put on ecosystem services? Well, you turn off ecosystem services and we're dead and nothing else matters. How do you put a dollar value on it? Well, you know, he'll argue in good ways why you should. And that's okay. And I respectfully disagree and sure hope you listen to him. Okay? And this, I don't know what evolutionary economics is.
This is from the reading. Can your system be implemented without total economic uproar within industrial societies? And if so, how?
I think my system would be implemented with far less uprooting to the economic system of the world. Not tomorrow, of course. Now, don't put me in charge. That would be disastrous. And we haven't trained a million people to figure out how you run agriculture and Wall Street and everything with this new concept. So that could be a problem. But I got a Wall Street Journal in the Albany airport, picked it up off the floor, and looked at all the economic indicators. And every single economic indicator all around the world is going in the toilet, except for the prices of commodities. So, are you trying to tell me that the world economic system isn't being disrupted now? But I think if we understood much better the relation of resources and didn't, I mean, all this hype and bubble of the year 1999 and 2000 in the stock market is just speculation. Well, we published a little paper on the relation between the price of the Dow Jones and the amount of energy used in the United States economy. Let me tell you, if you put your money in my model, you'd be way, way ahead.
Can it be done without that country experiencing serious disadvantages, or would the change need to occur across the board?
It's going to happen or not happen anyway. All I'm trying to do is understand it better. Now, maybe it's not going to happen. You know, maybe we're going to figure some way out of another speculative bubble, or find lots of oil in Vermont, or whatever we're going to need. Yeah.
Have you seen any changes happening in the mainstream economic?
No. You think they invite me to Yale? Get real. They did invite me to, the ag economists invited me to Cornell once. And RPI invites me there, but you know, that's like preaching at the choir. Going to Cornell, and one guy gets out and walks out in 5 minutes, and the rest 60 other people stayed, and they were very gracious hosts and were very interested. So, but they're ag economists. That's a different breed. They have to deal with reality. I like what Paul Ehrlich said. Paul Ehrlich's very funny. And he said, my daughter's studying economics, you know, and it doesn't bother me that she doesn't talk about soil or water or oil or fish or real resources. She said, I expected that, but the amazing thing is she doesn't even talk about money in her PhD work at Berkeley in economics. All she does is do math. I got a word for it, but it's too impolite, so you ask me that. Next.
How effective do you think the Bush push for a hydrogen economy will be in replacing oil use?
Well, first of all, we got to get them to realize that hydrogen isn't a fuel. Hydrogen's like a battery. It's a storage. So you can take energy from somewhere, a windmill or nuclear power or coal or whatever, and it might be stupid. If you got the electricity already, maybe you ought to use the high quality electricity and not convert it to losing 70% or something to hydrogen. But okay, you can do it. Split the water. My idea is take Eritrea at the end of the Red Sea, winds blow like the dickens there, people are poor, put up windmills there, split the salt water, make hydrogen run Europe. All right, let's try. Let's try. But don't forget, hydrogen is a fuel, and it's a way to go to a lower level of prosperity, but do it for a long time. And that's what we've got to learn how to do. And so I'm excited about that, I think. I've written a paper about it. Anybody want the paper? It's not published yet, like most of my good stuff. Yep.
I think that's pretty much.
That's it?
I mean,
that was easy.